I didn't realize that it was not recording the sound. So I have to say this one more time for you if you ever watch this again. So we put in the findings for horizontal asymptote at negative infinity being 0 and at positive infinity being negative 1. So this is done. We are looking at the first derivative finally. So f prime of x. The first function prime, e to the x, times the denominator, minus the numerator times the denominator prime, divided by the denominator squared. Please don't be tempted to do anything silly here, please. Okay, so I see that I can factor out e to the x, and then I have 1 minus e to the x, and this is out, but plus e to the x. We'll check everything in a moment. So I took this out, so I have 1 minus e to the x, but then there is a negative with negative e to the x, so it's positive. So it's e to the x over 1 minus e to the x squared. Awesome. This is undefined, the same thing at 0, so f prime of x undefined at the same point where the function is not defined, so no critical numbers. F prime of x equals 0? None, because e to the x cannot be 0. Remember the graph of e to the x. So this is always positive, this is always positive, forever positive. E to the x is positive and this is squared. And now no critical numbers. These are my findings. I go back immediately to the table. And now I make sure that these two work well together. If they don't, I have to go back to the drawing board and say, oops. So from 0 to infinity, yeah, that's okay. From negative infinity to negative 1, yes, that's okay. Awesome. Good. So finally, I'm discussing the second derivative. Okay, so this is the first derivative. So now the second derivative. The second derivative is 1 minus e to the x to the fourth power. The top function prime is e to the x times the denominator minus e to the x times, I have to differentiate 1 minus e to the x squared. I bring down 2, subtract 1 from the power, and differentiate the inner function, negative e to the x. Careful here, we want to clean it up maximum cleanup. I will factor out an e to the x. So I will factor out this and one of these. So e to the x and 1 minus e to the x. E to the x is out, one of these two is out, but one of them is left in. This is out, and now careful, negative 2 multiplied by negative e to the x. So it's positive 2e to the x. Any questions so far? Any questions? Yes, now I can do this. And then I continue, and this is my page 7. I have e to the x and 2 minus 1. So e to the x plus 1 over 1 minus e to the x to the third. Okay.
We weren't supposed to do anything with the denominator.
Say that again.
I thought we weren't supposed to do stuff with the denominator, like change it.
But I can I'm applying a legitimate operation. I'm allowed to simplify factors.
Okay.
So I simplify the 1 minus x from the top. And with the 1 minus x on the denominator, I only got 3. And now I'm asking myself 2 questions. Where is the second derivative 0? And where is the second derivative undefined? Nothing will come out of this because it's undefined where the original function is undefined as well. So nothing will come out of that. But I have to discuss this. This can never be 0. We know the graph. E to the x is never 0. But e to the x could be, let's see, it's positive. And this could also not be negative 1. It's because e to the x is always a number greater than 0. So nothing comes out of this either. Now I have to study the sign. This is positive, so I'm not going to worry about these two. However, the denominator is 1 minus e to the x squared, but times 1 minus e to the x. And this could be negative. This could not. This is always positive because it's squared. But power 3 can be positive or negative. Even power cannot. But power 3 is a problem. So when I plug in here to study the sign, I have to plug in values left and right of 0 because 1 minus 1 is 0. So I go back to my table. So there are no inflection points, but I have to study the sign here and the sign here. So I'm going to plug in like -3 and then plug in 3 or 10 and 10. It doesn't matter. So when I plug in 10 here, 1 minus e to the 10th, this will be a negative number. So the whole second derivative will be negative. Now when I plug in -10, then I have 1 minus 1 over e to the 10th, which is very small. So this will be a positive number. This is tiny, so small that this will overtake it. So it's positive. This was a long analysis. Long differentiation, limits, all sorts. But all the information I care about is in here. I don't need to look anywhere else. That's it. That's all I need to graph the function. That's it. So when I graph this, I have to graph or present the asymptotes first. So at -infinity, this is an overkill. There is no need. So y equals 0. But at positive infinity, I get y equals -1. Okay. So from approaching 0, and the left-hand side and right-hand side limits. So from approaching 0, increasing, opening up, going to infinity. Okay, let me use a different color. Coming from -infinity, increasing, opening down to -1. And this is the graph of f of x e to the x over 1 minus e to the x. Yep. So where's my page 5, 6, and 7? Okay.
Any questions on this? And yes, you can double check. Please don't start by plugging in the function to see how it looks, and then walk your way backwards, because credit will not be given for something like that. So please understand the work, and then you will never have to check first and plug in first, and it was minus e to the x, and close. Now, the calculator will not know, but we do know that we also need a horizontal asymptote at -1. There is no need to put the 0
because 0 is the x-axis. So that part is not needed. And now what is the viewing window? Oh, I can live with the standard this time. So it's coming from approaching 0. This is incorrect. You know that. It's not. It looks like it's overlapping, which we know it's not. It looks here like it stops here. No, we know it's not. So that's why I don't want you to rely on the calculator and say, oh, okay, this is what I have to graph, because it's incorrect. It doesn't stop here. It doesn't stop here. It goes forever to negative infinity, to positive infinity. So please don't copy something like this. A student who copies something like this, then I think that the student that didn't understand the process, just copied something from the graphing calculator. But this we were able to do in pre-calculus. Now we know a lot of steps, we understand a lot of work here, and what the first derivative says, what the second derivative says, and so on and so forth. So this is not about graphing this, it's about understanding the information and graphing. Any questions? Any questions about the process? Yes, some functions are quite long. I agree. Okay, I'm back to my book. I'd like to continue with, in section 4.4, we are going back to L'Hopital's rule. So this is my page 8. Yes, we'll have more graphing and more asymptotes in section 4.5. So 4.4. So we know that L'Hopital's rule requires a limit of, let's say, P of x over Q of x as x approaches A, where P and Q are differentiable. If they're not differentiable, then I can apply L'Hopital's rule. And if I get 0 over 0 or infinity over infinity. So limit, ratio, 0 over 0 or infinity over infinity, and these functions differentiable. Then this limit, as x approaches A, we discussed that, over Q equals limit of P prime over Q prime. Notice that this is never the way we differentiate a function, a rational function, ever. But this is allowed inside a limit, and if the functions are differentiable, and 0 over 0 or infinity over infinity. So we had examples. Do you think we should look at another example with 0 over 0 or infinity over infinity? Because what I wanted to talk in this section about is there are 7 indeterminate cases. Or situations. By indeterminate, we do not mean undefined. No, we're not talking about undefined. We're talking about situations in which anything can happen. That's what indeterminate means. Anything can happen. Okay, so we already encountered these 3. So this answer could be 15. This could be 0. This could be 1500. It means we have no idea what can come up. Okay, so let's look at an example and then move on to the other 4 indeterminate cases. So here's one. Let's say a limit as x approaches, yeah, why not, infinity, from the square root of x over 1 plus e to the x. Okay, where it's a limit, I have to estimate the numerator, I have to estimate the denominator. Where is the numerator going? Where is the denominator going?
is the numerator going to infinity?
Excellent.
Also infinity?
Excellent. So I have the limit. These are differentiable functions. I have 0 over 0. It's a ratio. I have infinity over infinity. It's a ratio. So I'm applying L'Hopital's rule. Can anyone give us the derivative of the numerator and the derivative of the denominator?
1 over 2x over ex.
E to the x. Perfect. So 1 over 2, the square root of x, over e to the x. So remember, this is over 1. I'm going to flip it. And I have limit. I'm not going to write here. I squeeze it in, and I don't want it. Okay. I'm looking now to make sure that I'm centered for you. Okay, so limit as x approaches infinity. And when I flip, I have 1 over 2 e to the x, the square root of x. And the answer is
1 over infinity.
good, which is
0.
excellent. Which means y equals 0 is a horizontal asymptote at infinity. Remember, this is not a pure rational function. If anything else in a rational function is involved, like the square root, e to the x, blah, 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 I cannot conclude. I have to check the other end, but this is not what we're asked to do, so there is no problem there. Okay. Let's look at one other example I'd like to look at. Okay, so let's say limit from sine x minus cosine x over tangent x minus 1 as x approaches pi over 4 from either side, they say. And this is problem, I'm sorry, 13. And that was problem, sorry, that was problem, yes, 19. Okay. So, can anyone tell us anything about the numerator and then the denominator? Anyone?
Is it 0 over 0?
Exactly. Sine and cosine are always the same. The square root of 2 over 2 minus square root of 2 over 2, and tangent is 1. 1 minus 1 is 0. Excellent. Ratio, differentiable, 0 over 0, limit. Completely all the requirements are here. So then sine prime is cosine, and cosine prime is negative sine with minus in front. And the denominator is secant squared. Let's try again. Where is the numerator going? Well, we know it's the square root of 2 over 2 plus the square root of 2 over 2. So this is 2, the square root of 2 over 2. So then the numerator is the square root of 2. Secant is 1 over cosine. So cosine is the square root of 2 over 2, and I flip it. So 2 over the square root of 2, but I also have to square it. So this is just a number. L'Hopital's rule is no longer applicable. I don't even need any rule here. So I have the square root of 2 over 4 over 2. 4 over 2 is 2. And this is it.